Okay, so guys, we're moving on to our lectures now on Osteichthyes. Please, those ones at the corner as well, please. Can someone turn those lights off for me? Please. Please. One of you stand up and go turn the lights off. Yeah. Okay, Osteichthyes. What are Osteichthyes? Huh? Someone is listening. That's great. Okay, guys, so what have we done? Okay, quick recap. This is vertebrata only. This is not chordata. Remember, the protochordates are not here. Remember the protochordates? Okay? You've got urocephalus, you've got urochordata, cephalochordata, vertebrata. This is vertebrata. You've got the agnathans, which are jawless. Gnathostomata that all have jaws. You with me? Cyclostomata means? Round mouth. Correct. And two of them, hagfishes and lampreys. Okay, life cycle of the lampreys you know, hey? With the metamorphosis. Hagfish and lampreys. Hagfish are scavengers, lampreys are parasites. Ostracoderms and placoderms. The only important things about these things was that the one has got no jaws, the one has got jaws, they are fossils only, but they've got some bones. The only important thing about these two is that they have bony plates, real bony plates. That's why they're between these two. Then the chondrichthyes, why don't we have fossils of chondrichthyes? They are made up of cartilage. Elasmobranchii, which is the shark, skates, and rays. Holocephaly, or the chimerians, which are the monsters. Look at the tails. Okay. Acanthodians, don't worry. I don't care about those acanthodians. Then Osteichthyes, that's what we're moving on to today. Osteichthyes, the bony fishes. Okay. So, Gnathostomata, Osteichthyes. Gnathostomata, Osteichthyes. What else is important, guys? Please, if you look at the development of the and we're going to come back to this graph a couple of times today. The way that you read this graph is to show you there's a hypothesized common ancestor for all of these fishes, including the tetrapods. Okay? So what are fishes? What's the definition of a fish? Huh? Yeah, okay. You guys are not saying it's loud enough. So all the vertebrata, excluding the tetrapods. Easy peasy, huh? So these are all fish, except these. Modern amphibians and amniotes. Amniotes that carry their babies around with them. Amnions, eh? Amniotic sac. That's what that means. These are modern amphibians. These are the tetrapods. So everything else here is the fish. Now, what this graph shows is based on the fossil records where you had diversification of different animals. Okay? So from these different periods, from the fossil records, they can show that some of these organisms were very common in different periods. But you can see a lot of them didn't survive. They've become extinct. Some of them, like the lampreys and the hagfish, is a thin line, partly because they will leave no evidence. Okay? There's no bones. Nothing. So we don't know much about them, actually. You see? But you can see the lines are very thin. Chimerians, you can see they were a lot more popular. Now they're a lot more successful, and now they're not as successful anymore. Only a few species. Sharks and rays, they've become very successful. Look at the bony fishes. Look at the bony fishes. They are the most successful group of vertebrates. Most successful, with a high diversification. 31,000 species. Okay, why have I drawn this arrow here, guys? It's because of your books. The textbooks show that there have been some changes. Can you see here? The idea here was from the Osteichthyes, you had this early tetrapod break. Now we've grouped them all together. See that? And now it's not the Osteichthyes. Look here. This was Osteichthyes. Now we've separated them a little bit more. We're going to come back to this picture in a moment. I just want to show you, this is the recent one. You see, as we get new information, it's changing. Okay, so what do we know? So the Osteichthyes are the lineage of fishes with bony endoskeletons. So the skeleton on the inside, exoskeleton outside, endoskeleton inside, that is bony. And they proliferated during this Silurian, to the early middle Silurian. That's the different periods. Yeah, so this period, the Silurian period here, is when they really started to diversify. Gave rise to the clade of vertebrates that contains 96% of living fishes and all living tetrapods. Okay, so all tetrapods and all fishes belong to this clade of Osteichthyes. Okay, but then what are fish? All of the vertebrates excluding tetrapods. Okay, bony fishes are related to tetrapods. Why? Because of the presence of this endochondral bone. Endochondral bone is that the bones, the actual endoskeleton, has been replaced by this bony substance, this hard bony substance. And that is a characteristic that's shared between the Osteichthyes group and all the tetrapods. Okay, just check it's recording. Yes. Endochondral bones. Okay, the presence of lungs or swim bladder that is derived embryonically from the gut, actually the esophagus. Your esophagus is what you swallow food with, okay? So that swim bladder is embryonically derived from the gut, okay? Swim bladder, we're going to talk about that as well now. Several cranial and dental characteristics as well that are unique to this group. Okay, because of the monophyletic origin of the clade. So the monophyletic, remember we talked about polyphyletic and monophyletic long ago. And the idea is that there is probably one origin that's given rise to these characteristic species. If you had two different origins and they have two characteristics but they look very similar today, it would be poly. Okay, so this is monophyletic. So due to the monophyletic origin of the clade, we call it Osteichthyes, but it includes fish and tetrapods. Okay, that I'm not going to ask you that. That's just background. By the Devonian period, the bony fishes diversified into two major clades, Actinopterygiae and Sarcopterygiae. Okay, those are the two different clades. That's important, guys. You need to know that there's a big difference between the ray fin fishes and the lobe fin fishes. What is the lobe fin fish that we were talking about last week? The coelacanth. Okay, you guys need to get that right. It's written here: coelacanth and tetrapods. Okay, interestingly, our Sarcopterygiae group is not very well diversified. As you can see here, look here, you can see that there were periods when they were more common, but today we have very few. Can you see how thin the lines are? Okay, so there's only 8 species, but they share the characteristics with. So there's a hypothesis that they derived from there's an ancestor of all fishes, all tetrapods, and the lobe-finned fishes, Sarcopterygiae, that gave rise to this group. So you can see that it's this group then that has become quite dominant as well. The tetrapods, the land-based vertebrates, hey? Okay, so they are more closely related to, in terms of their structures, to the Sarcopterygiae, the lobe-finned fishes, than they are to the ray-finned fishes, even though all of them have got bony endoskeleton. Cool. Okay, endochondral ossification is a process during fetal development of some vertebrates' skeletal systems by which bone tissue is created. That's what that word means. Okay, as I said, it's just the bony formation that you have from your cartilage into this bony substance, which is characteristic. Okay, what makes them so successful? Do you remember this picture? Okay, those are one of the characteristics that make the Osteichthyes so successful. 3 things. The operculum. So the operculum is the plate that covers its gills. And because the operculum is bony and it has muscles attached to it, it can actually create negative pressure. It can pump like this. You see? And because of that process, it can help to move and ram water over its gills, which allows it to obtain better oxygen circulation over its gills, which gives it more access to more oxygen, which contributes towards their respiration. Gas-filled pouch derived from the esophagus. We call it the swim bladder. Have you ever cut a fish open and you take out this bag, like a spongy bag? It's a swim bladder. If you guys do more work with me towards your advanced diploma, we'll definitely show you some swim bladders. It's very useful for gaseous exchange, so they can actually get some oxygen out of it and store some oxygen, and helps them with their respiration, as well as buoyancy. Very important. So a fish doesn't have to keep swimming to keep in the position he wants to in the water column. he can put gas in or out of that bag, and by doing that, he can move his body up and down like this in the water column. Did you know that? He doesn't have to try to go to the top. He can just fill his gas bladder up a little bit, and he'll come up a little bit. And he'll let it go down a little bit, he'll go down a little bit. Do you understand that? So he doesn't need to swim. And then very importantly, the jawbone development, and this is also related to the structure and the muscle attachment, which allows them to suck fish in. You can see how successful they have become. Okay, 31,000 species. 31,000 species. So we have got a lot of work still to do because we haven't discovered all of our species. Okay, I just want to go through the characteristics, and I'm going to refer to the pictures as I go. The caudal fin is the tail fin, eh? The caudal fin. Remember we spoke about sharks that have heterocercal tails? Now you have homocercal tails. Okay, that's also very useful for fish. Okay, so some of them have got heterocercal tails, few, but the homocercal tail is very useful for fish because I think we're going to get to that in a moment as well. Yeah. Oh, we're going to move on to that in the next slide. Okay, so let me just talk about some of these characteristics. So what are we interested here to look at? So we're going to look at the circulatory system. Here is the picture of the swim bladder, where the swim bladder occurs. Lots of bone attached to the rays, which gives it strength and stability. And then in terms of the homocercal tail, you can see that these bony rays extend from the skeleton of the fish inside, which gives a lot of support and a lot of ability to swim strong. So the sharks and things, they have heterocercal tails as well. But in terms of their attachment with the rays that are attached from their endoskeleton, it gives them a lot more strength and support. Okay, so it's a lot, they're very successful. Then we spoke about the different scales. Do you remember the scales? So in the cartilaginous fishes, the chondrichthyes, we have these placoid scales, which are dental developments from the dermis. Now we have true scales. Okay, it's also derived from the dermis, but they're very light. Okay, these scales are very light. There are three different types of scales: ganoid, cycloid, and ctenoid. You don't say the C. Okay, ctenoid, ganoid, cycloid, and ctenoid. Cycloid and ctenoid scales are very common in bony fishes. This ganoid scale is very uncommon and only belongs to one group of fish that actually occurs in Africa. And this is them. They're called the bikers. Okay? So the bikers are the ones that have the ganoid scales. If you go through your textbooks, you see that they just refer to, it's very surprising that we have a group of fishes that's freshwater and in African lakes and rivers, and they have this ganoid type of scale, which is very uncommon. Okay? So in many cases, this group of bikers are not very well developed. The chondrosteans doesn't look very similar to chondrichthyes. Remember, we have chondrichthyes, which are the sharks. Now we have chondrosteans. And the reason why it's called chondrosteans is because these sturgeons and the paddlefish, they are bony fishes and they have characteristics of bony fishes, but most of their skeleton has still got remnants of the cartilage. So they're more of a transition species to the true bony fishes that we have. The third one is the neopterygians, which is the true telos. And the true telos or telios are the bony fishes. Okay, let me take a step back. Sorry, because I'm mumbling away a little bit. So if you look at some of the older fishes, whoops, wrong direction. Some of the older fishes is of the Osteichthyes group. Okay, the Osteichthyes group has got these three types of scales: ganoid, cycloid, and ctenoid scales. Okay, that's one of the characteristics. What's interesting about these different scale types is that this ganoid scale, which is very old, it's not prehistoric, but it's very simple, not advanced compared to these type of scales, belongs to one group of fish. And that group of fish occurs in Africa. It's called the biker. Okay, the biker. By the way, that fish has got a very interesting dorsal spine because it actually has two rays of bones along its dorsal spine. And if you grab it, it can actually cut your hand by rolling its spine over you. Crazy, eh? Like a pair of scissors, the bikers. That's the first thing. The next thing you need to remember is that the Osteichthyes have got this this homocircle tail, which is very predominant, okay? Now remember, the sharks have got the heterocircle tail, but some Osteichthyes have as well, but it's uncommon, okay? Then the holocephalines, the chimerans, they have this dicircle tail, okay, which the coelacanth also has. You remember? So there are few individuals that have this type of tail formation, but the majority have the homocircle tail. Okay, and the homocircle tail is very useful because with the rays that extend into the caudal fin, it gives them very good movement. Okay, so I just wanted to explain the tails and the important characteristics associated with the tails. I wanted to explain the important characteristics associated with the scales, okay, of the Osteichthyes as a group. Then we move on, and the Osteichthyes have been divided into 3 clades. So there's 3 groups: the bikers, the chondrostenes, and the neopterygians. The neopterygians is what has given us the teleos, and the teleos is the major group of bony fishes. Okay, so ideally I'd like to go from the Osteichthyes to neopterygians to telos. That's what I want to do, but I mustn't forget about these other 2. And all that you need to know about the bikers is they've got ganoid scales, and they are very simple. So they are old Osteichthyes. Then the chondrostenes have got characteristics of the sharks, which is in the form of cartilage. They've got a lot of cartilage in them. Okay, Atlantic sturgeon and the paddlefish. Okay, can I move on now and just focus on the neopterygians? Okay, because that gave us the teleos. And it's these teleos that we're going to focus on now. Okay. So, yeah, we need to just make sure it's clear. Sorry, guys, I know there's a lot of things to remember. But remember, under the Osteichthyes, I just want to recap. Under the Osteichthyes, you've got Actinopterygi, which are all the ray fin fishes. Then you've got Sarconopterygi, which includes the lobe fin fishes, the lungfishes and the coelacanths. And they are also closely related to, in terms of their forms, the tetrapods. Okay, so you're going to be able to differentiate between Sarconopterygi and Actinopterygi. Actinopterygi, which are the ray fin fishes. Okay, large group, lots of different individuals, lots of species. Okay, this is where we're differentiating between Actinopterygi, and there, the major group is the telos. Then with the Sarconopterygi, we've only got 8 species. The Sarconopterygi are the coelacanths and the lungfish, only 8 species. But they are closely related to the tetrapods. Okay, then we spoke about the different types of tails. Okay, but we're referring here to Archanopterygi, that group of Archanopterygi. The tails, we spoke about the tails, different types of tails, heterocircle, dicircle, and homocircle tails. Okay? You're going to have to learn this, guys. The scale types, we've got ganoid, cycloid, ctenoid. Ganoid belongs to the fish group, the group of fishes called biker. Exactly. Bikers, where do they occur? They occur in Africa, correct. So in terms of the clade of the Actinopterygi, you've got bikers, chondrostenes. Chondrostenes are closely related to what? Why? Perfect. Neopterygians gave rise to the telos, which are the true bony fishes. Okay? 29,000 species. So this is by far the most dominant group. Okay, why they're so successful? Very thin, flexible scales, light armor, light body armor. Do you guys know, you remember the stories about the knights in Europe, the knights in shining armor? Huh? Why do you think that in Africa we didn't go through that phase where we had armor? Well, firstly, it's hot. But why was there no armor? Because I can just run away from him. He's this guy with steel all over. What's he going to do? Huh? He's going to run after me. I'll run away from him. And then when I'm far away from him, I'm going to turn around and I'm going to shoot an arrow at him. Do you understand? So armor went away because people would just run away, turn around and shoot them. What a silly idea. And then armor disappeared overnight. Okay, so the fact that these fish are light, can you see the comparison between having to run around with this heavy armor around you? I can run away from you. Hey? I'm quicker than you. So relatively, they are a lot faster and quicker. The homocircle tail, remember I spoke about the homocircle tail and the rays that help them attach to the tail. That's very useful. Hey? Helps them go faster. Or it's more stability and more support. The swim bladder, derived from the what? What is the swim bladder derived from? Where does it come from when the embryo is developing? From the esophagus. What is your esophagus? It's the pipe that you swallow food in. Part of your gut. Gastrointestinal tract. Suction feeding. Muscles attached to the jaws and the jaws development, which allows them to be very effective predators. Okay, of the Actinopterygii is a part, which group of fishes? Osteichthyes. And if you the other group of Osteichthyes, apart from Actinopterygii, called the Sarcopterygii, okay, which is the coelacanths and the lobefin fishes. So you guys are getting there slowly. Now I'm going to go through it. Homocircle tail again, very important. Paired pectoral and pelvic fins usually. It helps them with swimming and support and strength. The bony rays, supported by bony rays, that control fin movements within the trunk. By having bony rays, guys, the teleos fishes are the first ones who can actually do this very successfully. A shark has just these rays, these fins that stick out. He can move them, but it's very cumbersome. You see, where a teleost, he can do whatever he likes with his fins. You understand that? That's a good development. Skin with ganoid. This is called an ancestral condition. Which species, which group of fish have the ganoid scales? The biker. Where do they occur? Good. Cycloid or ctenoid scales of dermal origin. It comes from their skin. Some of them are naked. Some of them are naked. What does that mean? That means they have no covering. Anybody got an example of a fish that's naked? Anyone? Tell me a fish that has no scales. No, man, that's not a fish. I'm going to put that in your exam. Okay, jellyfish is not a fish. Jellyfish is an invertebrate. What? Catfish. Perfect. Exactly. The skeleton of bone. The notochord is present but reduced. Guys, what about the Sarcopterygii? What about the notochord in the Sarcopterygii, the coelacanth? Do you remember from the movie? The notochord is still well developed, a hollow tube. Very important. Vertebrae are distinct. The jaws are present with enameloid polyphyodont teeth. What does this polyphyodont mean? Hey? The teeth replace themselves continuously. What other organism has polyphyodont teeth? There you go. But these are now enameloid. So you've all got enamel on your teeth. Enamel is something you produce to make them strong and hard, which is from here. Spiral valve, don't worry about that. The brain is well developed but small, 10 pairs of cranial valves. Brain is well developed. They are smart. Smart. Some of them can even communicate with electromagnetic sensors. Some people in Europe, guys, were taking these mormyrids, little dolphin fish we catch here in Africa, put them in a tank, and when bad chemicals come through the water, the fish scream. Help! They scream. They don't say help, but they scream. And they let off the signal to say, problem, problem, problem. And then it comes on your cell phone to say, the mormyrids are telling us there's a problem. What? Semicircular canals, that's not serious. Sexes are usually separate. Guys, this is important. The sexes are usually separate. Okay, this is some later developments. But some are hermaphroditic. Hermaphroditic, again, remember we spoke about this before? The male and female sexual reproductive organs in the same organism. Very few reproduce asexually, but parthenogenesis. Parthenogenesis is a process where, because they have both male and female organs in the same organism, they can actually produce offspring themselves without needing to have another partner. You understand that? It's very rare. Fertilization usually external, internal in few, but it's usually external. You understand? We have to generalize to say what is the common attributes of the fishes. Sexes are usually separate. Oviparous. Oviparous or viviparous. Oviparous, you release eggs into the water. Remember from the sharks. Viviparous. Okay, Dan said you guys must meet at 12:30. With you. Okay, sexes are usually separate. Guys, I'm going through this, because we don't have time. Oviparous, you lay eggs. Viviparous, they develop inside. Remember the sharks, vivipary, okay? Nourished from the placenta or yolk sac. Remember the difference. Ovovivipary has the yolk sac. Ovovivipary. You need to learn those things. Don't be confused between oviparous, lays eggs. Don't be confused between oviparous, lays eggs, and ovovivipary. That is that egg that's laid inside, but it has got a yolk sac. So the ovovivipary. See, the words are hard. You got to get your tongue around it, guys. Okay. That's very important with these different fishes like the sharks. You need to learn this, hey? You will be asked some definitions. Don't get confused between oviparous and ovovivipary. Oviparous and viviparous, you can compare directly. Vivipary, you've got two types. You've got placental and ovovivipary. Okay. Excretory glands are opistonephric kidneys. Opistonephric kidneys, remember we spoke about the pronephros, mesonephros, and opistonephros kidney, the different types of kidneys. They are just important for excretion. Okay, for different types of excretion. All I want you to know there is the differences between a pronephric, mesonephric, and opistonephric kidney. The first development, middle development, advanced. That's all. So these are more advanced. That's all you need to know. They're more advanced. The gills are covered by a bony operculum. Swim bladder is also present. The bony operculum covers their gills, and it can actually be used as a pump. The swim bladder is derived from the esophagus or the gut. Helps with buoyancy, used for respiration. Heart with a sinus venosus. Remember the pumping way that it pumps. Central single circulation. Okay, that's all. Then, this is the last slide. Sarconopterygii. Actinopterygii, Sarconopterygii are two groups of the Osteichthyes. They're all the bony fishes. Sarconopterygii called the lobe-fin fishes. Really crazy di-fi-circle tail. Sorry, must get it right. Di-fi-circle tail. That's why the discovery was so crazy. Eh? Remember the whole story about the coelacanth? Latimeria. I hope some of you are doing that practical because it's easy. Remember the article that you need to look at as well is stuck on my window of my door of my office. Okay, Latimeria. What is important about them? Di-fi-circle tail. Di-fi-circle tail. Shall I say it once more? Di-fi-circle tail. It's very old. Paired, pectoral, and pelvic fins that are lobe-like. Okay, lobe-like. When we get onto the amphibians, we're actually going to talk about the structure in those lobes, because it's not like the Actinopterygii. By the way, that's dangerous. I just noticed there. Did you see that? Don't get confused about this. I'm going to change it quickly. Rather now than forget it, eh? You see, I've just got a label here that's wrong. Okay, I changed this, guys. I changed the label. Sarcopterygii. I changed the label. It said Actinopterygii, now it's Sarcopterygii. Lobe fin fishes, they're all part of the Osteichthyes. Caudal fin, heterocircle, or dicircle. Okay, dificircle, living in living forms. Paired, pectoral, and pelvic fins, lobe-like. Okay, the structure is different. We're going to talk about that. Skin with dermal scales, composed of 2 layers of bone, a layer of cosmine, or formed, yeah, but that's not, I'm not worried about that too much. Enamel in fossil species, skeleton of bone, polyphyodon teeth covered with true enamel, same as the Actinopterygii. Brain is well developed but small, 10 pairs of cranial nerves. Senses are variable, 3 pairs of semicircular canals. Sexes are separate, fertilization external in lungfish or internal in coelacanths. Do you get any ovovivipary? What's ovovivipary? Huh? Yolk sac, but internal development, eh? That's what they have. That is what they have. Okay. With the development. Remember from the story, you can see that they actually give birth to pups. They call them pups. That come from that are developed inside the adult. Oviparous. Oviparous means that they lay eggs, but we know from the coelacanths that they're different. You see, there's some more information we have. See. So they say they all lay eggs only, but we know that from the coelacanths, the larvae young develop inside the coelacanth. Do you understand? So even this information needs to be updated. You with me? Because that was only discovered a year and a half ago. Excretory system of opisthonephric kidneys, which is highly developed. Gills covered by a bony operculum. They have the swim bladder as well in the lungfish. But it's filled with fat, like oil in the coelacanth. Remember they spoke about oils. Remember with the swim bladder of the lungfish is actually developed into a lung that it can actually use to breathe. Okay, that's very important. Heart with sinus venosus and atrium, that's very simple and fine. All right, then I've given you guys a bunch of YouTube videos I want you to look at. One of them is quite important because of the lungfish. There's one more thing I want to talk to you about the lungfish, guys. Guys, please.